I'll give you a presentation of EBRAINS Research Infrastructure. This is infrastructure for brain and brain-inspired research. And I will focus on EBRAINS providing global access to tools, services, and resources. So in my talk, I will talk about the multiple layers of the EBRAINS Research Infrastructure, the services that are included, and I will dive into one of these services, the data knowledge services. I will also mention briefly how the EBRAINS services are using INCF resources and network, and how we interact with other brain initiatives and stakeholders through the IBI. Also, I will give a comment on open science and as well on how the different players in this area are working together in open science movement. But first, a few comments about the EBRAINS research infrastructure itself. So in order to understand what a research infrastructure is, one would need to understand that there are several layers. There's a base infrastructure, which is made up basically of the machinery and the high-performance computing facilities that we have as a backend. Then we have tools and services that are installed and running on this basic infrastructure. We also store data, which is critical, of course, for their tools to be used. And we have a community around this, where you may want to be a part of that community. The data part comes in through a curation process into a system which allows the data to be organized, connected to brain atlases, and connected to the various tools for use of the data. You can find these tools through a search user interface that we will return to in a moment. And then you can have access to various types of analytical tools and use various workflows. Some of those workflows are focused on model building and then leading to use of our simulators and simulation capacities. Very importantly, we have a high-level support team, which provides support to all users of the EBRAINS research infrastructure. This would apply to sharing and publishing data and models through EBRAINS, and it would apply to using tools and workflows of all the services that are available through the EBRAINS web portal. We also have a voucher program. This is now coming towards the end, but it illustrates the key point that the Human Brain Project, with its EBRAINS research infrastructure, is very much open to the outside. So this voucher program has supported the infrastructure needs of other projects from around the world. Most of them are in Europe, but also from some other places. And we've had more than 40 projects connected as so-called voucher to the voucher program, meaning that we have allocated resources inside our project and in EBRAINS to adjust and develop features that are required for these external projects. And we have added all throughout the lifespan of HBP new partners through open calls. So this is very much an open project communicating with its surroundings. So EBRAINS has a set of services. They are listed on the left side. Data knowledge services that are there to facilitate sharing of and access to research data, computational models, and software. Atlas services that are used to navigate the brain, to find data relevance in different locations, to be able to compare information based on location and analyze data in this context. The simulation services to conduct sustainable simulation studies and share the results of these simulations. Of course, building very often on the data that you can find in data knowledge services. And brain-inspired technologies, which is about different aspects that I'll show you briefly, which leverages the computational capabilities of the infrastructure. And also medical data analytics, which is a service that provides access to medical data, data from patients and research subjects in a more clinical domain. The access to services are at different levels. We have open services, that is, for example, most of the data knowledge services, and also several other services, atlases and simulation. And the general support for the services is also openly available. Then we have some access control services. In order to use those, you will have to have an EBRAINS account. And I think many of you, or hopefully all of you by now, have an EBRAINS account. And then you will be able to also access these services. Then there are some services for selected users. They require much deeper support and access to the most advanced computing. And that's also possible, but that follows specific applications for the given suggested activities. So let's take a little look at what we have in the EBRAINS services. In addition to those main categories you can see on the left slide, we have a so-called Collaboratory. This is a key instrument for researchers and developers to interact in an environment where they can work in teams. It's a workspace. It manages who will be part of the workspace, identifies the users and so on, and allows the users of the Collaboratory to organize different groups and units and to say that this group or unit is only for me, or is only for the people I add to it, or I make it public so that anyone can see it. It has a wiki service which hosts the main interface to access all Collaboratory services, and Drive, which allows you to store files, so-called lab service, Jupyter Lab environment for notebooks, which is a way of programming interactively and using some of the services. I believe you will probably hear more about in some of the demonstrations as we move forwards. It also has standard tools for working with documents, referred to as Office. And it has so-called buckets, which is a term we use for the larger storage that might be required for large data files. This is important when you work inside the Collaboratory and connect to other services. You may need access to some larger space, and this is possible through this bucket service, larger storage space for your private use. So, as I mentioned, there is a base infrastructure. This is scalable interactive compute services. These are so-called data and cloud services for sharing and collaborative research, and they are based at 5 supercomputing, high-performance computing centers in Europe that are shown here. That is at the CSCS in Lugano, Switzerland, Jülich Center, and the CA, the Barcelona Supercomputing Center, and Schema. So they make together our base infrastructure part. You can find these different services at ebrains.eu. And this is what it looks like. If you go in there, you've probably been there already. And by choosing either the hamburger menu at the upper right or the services button, you will be able to find and identify different types of services and can then navigate the system. I'll go a bit more deep into this one later, but just as an introduction, the data and knowledge services consists of a shared data service, or more precisely, shared data models and software, which introduces the user to a curation workflow that allows you to bring something into the data and knowledge services through a control process. Then there is the find data service, or more precisely, find data models and software, which allows you to go through a graphical user interface and simply search using free text or other control terms to find the information that's been stored in this system, the research data, models, or software. Atlases services will be something you will hear a lot about in this multi-class series event, and it has different aspects. It has a multi-level human brain atlas with many features. It has a rat brain atlas, a mouse brain atlas, and it has tools to integrate data in atlas space, that is to bring research data into the atlas space and connect it to location, and to analyze these data in atlas space. The human brain atlas is a key aspect of this service and a very large part of it, developed in the HPP. The rat brain atlas is also entirely HPP built. The mouse brain atlas uses the Allen Brain Institute mouse brain atlas that is, of course, very well known in the field of experimental mouse research. And then we have the tools, which are again developed by HPP and brought into this service. Simulation will also then be a large part of the course. And as you will see on this slide, and probably you'll get even more updates than what this slide shows very soon, we have cellular level simulation tools, network level simulation, whole brain simulation, and data analysis visualization tools connected to this. So there is also the level referred to as molecular, which is not shown here, which will also come into the services. As you will see, there are several different services under each of these main levels or categories, and they will be reorganized also in the future so that some more are brought together a bit more than they are at this point in time. But together, the EBRAINS simulation services offers a very broad range of possibilities for performing simulation efforts. The brain-inspired technologies has essentially two parts. One is neurorobotics, which you may consider as an extension of the simulation. It's a type of simulation which simply builds on bringing your model into a virtual body, so embodiment, so-called. And that gives very new opportunities for testing models and performing a quite different type of simulation. The Neurorobotics platform offers this opportunity, and it's entirely virtual. So that means we're not talking about physical robots that move around in the room. We're talking about something you do entirely virtually online, and therefore very flexible and scalable. Then we also have services for so-called neuromorphic computing with two systems. One is Spinnaker, based in Manchester, UK. The other is BrainScales, based in Heidelberg, Germany. And these are a little bit different systems for emulation and simulation, but what they have in common is that they are more brain-like than other classical computing systems. The medical data analytics services consists of two main pieces. One is available at this point in time, referred to as the medical informatics platform. And this is a platform that connects hospitals at the moment in Europe. So this one might be a bit more difficult to go in depth into from outside Europe, but there are also examples of use from outside Europe that you can do. At this point, only on synthetic data. But for those who are part of this federation of hospitals, the idea with the MIP, the Medical Informatics Platform, is that they do not share their data. They only make their data available inside the hospitals, but a user of MIP can access the data without seeing them and performing analysis on data that are connected to the system, also across hospitals. So that offers some unique opportunities for analysis. And the other service is not yet online. It's indicated by the lower figure. That is a so-called service for Intracranial EEG Analysis. It will have a database of data from patients that are preparing for epilepsy surgery, where they, before the surgery, have electrodes implanted to identify where the disease is taking place. And this gives opportunities to collect a lot of data about activity in the brain that are brought into the brain atlases and will be available through this future intracranial EEG service to be launched later this year. Of course, talking about tools and services is not just about individual bits and pieces where you can pick from many of them. It is also primarily about connecting these different tools and services. So if we take an example here, from the left, you have groups, clusters of data, various data sets from experiments. Through a curation process, it's possible to connect them and bring them into some common kind of space, which is called a knowledge graph. And I'll explain to you in a moment what a knowledge graph is. And also to connect the data to locations in brain space, to different brain regions. Just like in geography, we know that we all use maps of the surface of the Earth to have information connected to location, which in turn is absolutely essential in our daily life. And of course, is absolutely essential when trying to understand the brain and trying to interpret data. If you don't know where they are from in the brain, it's quite difficult. Then to take the data and analyze the data using tools and workflows and bring them into different contexts through the research infrastructure is the basic idea, to produce various types of outputs that can lead to a better understanding of brain function. These different services we looked at all focus on being connected to a user community. So for example, in the eBRAINS web portal, you will find support. As I already mentioned, we have a high-level support team. It typically receives around 300 requests per week, probably more now. It says more than 30 warranty projects. It's actually more than 40 now, so it's going fast here. And on some of the service pages, you will find what we call a community section, which will have forum pages, which will have point you to GitHub, to conferences, to dissemination events, and news about the progress and use of these services. The picture shows an example from the Nest simulator and the community section shown there. So we will be adding such community sections to all the service pages so that you not only will be able to find services, go in there, start considering whether you want to use them, but at the same time be informed about what kind of community is there here. What else could I learn about this in addition to what I find on the web pages? And as you will see on the Collaboratory resources that we make available for each of these services. Two important things to note. There will be community sections on all service pages very soon. And there will be a new community space, which is a new service, which our inclusive community building task is building. And that will come later this year. So we will probably be able to inform you about that when it's up and running. And you might want to be early testers of this type of community space and interact with other researchers on the topics you're interested in. So then I wanted to tell you just a bit about the eBRAINS data knowledge services, because these services connect to almost everything in eBRAINS, and indeed very much to the Atlas services that you will be hearing about and the simulation services. So again, the services are discovered in different ways, for example, by clicking on services and identify them and going into them. And if you choose data knowledge, you will see these two: share data models and software, and the other service is find data models and software. So the data knowledge services are built around what is referred to as a knowledge graph. That is a so-called unlimited graph, allowing infinite expansions of metadata and linking. So the point is that this is not, for those of you who would be aware of what a relational database is, it is not a database with tables and very strict boundaries. It is more flexible. It allows you to connect elements in a structured way, and we impose necessary control on how these connections are made. And in this way, we create a system tailored for brain research and useful for scientists, and scalable with new approaches and methods and so coming in all the time. So it has originated from the HPP research. Without that, it would have been very difficult to get this started. And it's now targeting the broader brain research community outside HPP. The key feature of the system is that it accepts heterogeneous data and file formats. that makes it easy for anyone bringing in data because they don't meet a number of requirements saying that, sorry, we can't take it. So we are very positive to trying to take most of what is possible to bring into the system. That comes at a certain cost because it means that the level of standardization is not always 100%. There can be some variations. There are many data modalities, therefore, a broad collection of content. And for this reason, we also focus on gradually trying to impose more and more recommendations, guidelines, and standardizations. That is to help the field create something which is comparable across labs, across the subdisciplines of neuroscience. This is essential. And in this regard, actually, INCF is an important body. It has been mentioned before, and I'll return to why that is helping us with this. And of course, a key feature of this service is that we are providing a lot of open access to data. There are sometimes more controlled access, but in principle, open access and opportunities for reuse of the data. So if you choose to navigate to Share Data Service pages, you will find a page that tells you exactly what you can do if you have a great collection of data that you think should be shared with the community. You may want to publish just like, or you will, of course, publish just like you are used to, but you will also think about then, will you make your data available and allow for much more attention around the research you're doing and much more coming out of it? So we summarize on the web page what our offering consists of and give some high-level arguments, so to speak, for why you might want to use it. So this allows you to publish more of your work in a high-profile online resource, to integrate the data and your results with those of others, to make the data available in a context where they can be analyzed with other eBRAINS tools and services, to make your data citable and facilitate wide recognition. And also, you will be then offered long-term storage solutions for these data. So it all starts with a curation request. So that's a form which is fairly easy to fill in. That is allowing us to identify who is where is this produced, who is the originator of it, and to see if we can take the data. It's a matter of prioritizations and capacity, and we'll do our best to include as much as we can. A key point is that you may want to look at how to bring data to this system at the same time as you publish a data set in a peer-reviewed journal. And we have different tracks for this, so to speak. Then there is a data curation wiki available on the web, which tells those who are very interested in exactly how that curation process works. You do not need to read all about it, because we also have curators that can actually interact and help you and provide you exactly what you need so that you can respond to it and be able to add information to your data that we refer to as metadata. So data organization is the key point here. We're looking here at some of these infographics that we have there that one might look into, those of you who are interested in this. The key point is that you need to have some so-called schemas, or let's call it some kind of standards for how you use the words. You need to control the vocabulary, because if you use many different words for the same entity or item, it will be very difficult to interpret and compare. So this level of elemental standardization is needed. We therefore develop what we call the Open Minds metadata schema. And it's developed not just inside HPP, but in close collaboration with also scientists outside HPP. So it's intended to become a standard for curation of and adding metadata to neuroscience data so that they are made more comparable and easy to interpret. This is something you get help with if you bring data into the system, and that you will benefit from if you use the system. To illustrate the point with working with journals, the Share Data service, we could take 3 imaginary researchers. Let's call them Earl, Florence, and Sharon. Now, they have found through our Share Data service pages that you can publish a data set accompanying a peer-reviewed journal publication. And let's look at what they decide. Now, one of them, Earl, he aims for early stage sharing of research data. He wants to share the data before publishing a journal article. That's an option, and there is a route to explain how you would do that. In many fields, this is done all the time. In neuroscience, it's typically not so often done, but many are catching up and consider this now. Now, let's look at another person. Let's call her Florence. She wants to make her data findable. She wants people to discover what she's doing before a journal article has been published. But she would like to have the data under an embargo. She didn't want to show the data before the publication is out, but to make people aware of the research, to see what it is, to be able to search and find the work she's doing and information about it. And then let's imagine a third researcher, let's call her Sharon. She wants to prepare her data for the sharing, but she wouldn't like to share anything, not even the fact that the research is ongoing, before the journal article is published. That's also a possible track. That means there's everything released in one go. So these are the precise options that one will find on this information page. And that gives you some heads up in case you will want to be using one of these tracks. So how do you find the data that are brought into the system? You can use a graphical user interface called the Find Data service. And that allows you to enter free text to search for terms, or to use some of the filters in the left column, which allows you to choose among the control terms and to see what kind of combinations you can get out of that. Then you will get a list of hits, search results, and you can click on one of them and go into what we call a data card, or it could be a card showing a model or showing a particular software that is of relevance for the data, of course. So what has happened is that very diverse content and formats, as we talked about, has been brought into the system. It has been sorted and connected to the knowledge graph so that you, through the search user interface, can identify maybe a particular metadata tag, a particular word that characterizes the data, and thereby they show up on the search results list. When you found these data, you can either download the data sets or you can work with the data sets using tools and services that are available. And there will be an increasing number of such tools and services connected to the data. We're working intensively to try to add that. But at the moment, everything shared can at least be downloaded and worked on locally. So in the context of working with the data, the so-called API or programmatic access to the content in the knowledge graph is another route that you might want to prefer if you are a more advanced user, instead of using the graphical user interface. So that's something you can apply for access to. If you have an EBRAINS account, then you can use the Jupyter Hub and work with these features available through the Collaboratory system. So if you have used this service and searched for something and you find a particular data set, what will you actually find here? Well, you will find the title of this research and a description of the data set. You will find the names of the people that have contributed to the data set. If you click on one of those names, this is at the top level here. If you click on one of these names, all the data sets that have been contributed by that person will show up, so you will see all the related research. You will also see a link to projects that contains data sets from the same author. A project is an umbrella which covers collections of data sets decided by those who contribute the data sets. So instead of just having separate pieces, they may create collections, which we call projects. You can then download these data sets and look at the content. You can also choose to look at detailed descriptions of the data, a so-called data descriptor. This is something we are placing more and more emphasis on. There will be links to brain atlases and different types of metadata available describing the methods and modalities of research. And of course, in many instances, there will be journal publications for exactly this collection that you will also find. But this focuses on what is the research behind, what does the data look like. This is what you get here. So the EBRAINS data knowledge services are working, we are working, of course, with animal research data, but also with human research data. And this poses some challenges. At the top row, you will see the terms raw, pseudonymous, or pseudo-anonymized, and anonymous. Below, you will find some other terms that are used in different countries and places around the world in different ways. Personal data, de-identified data, and aggregated, anonymous, and so on. So there are many terms. Now, the upper row is what we have to use, the term we are using in Europe. So we don't want anyone else to necessarily use the same terms. We just have to inform you how we are using the terms. So now, when human data are brought into research, the individual data will have direct identifiers. If the data are very raw or so-called very personal, then it can almost be birth dates and even names and where people live and stuff like that. That's obviously nothing you want to share in general. Then there are indirect identifiers. There are certain features which makes it possible to find back to the individual. So as you go from left to right in this table, it becomes more and more difficult to trace back, to go back to the individual. The two columns to the right and anonymous, they represent data that cannot be traced back, not by anyone, also not by the researcher. So it means that if you have a data collection of human data, you discover an error, you can't correct it. You will have to replace the entire database. If that's the case, then you have anonymous data. These data we can share. If we want to share something more to the left, under the pseudonymous category, we need to control, because there are certain, even very low probabilities of identifying individuals. This is the way we work with it under the European legislation, and that influences how our services are built. But I think everyone would agree this is a sound principle. And then it is about developing practical solutions that allows us to work internationally with also human pseudo-anonymized data, which is of course very, very important. So we, at the moment, have services that cover this anonymized data, and you will find such data in the knowledge graph we have or in our find data services. So we are stretching it to now go into this domain. And this is something you will see come in the near future with more announcement around how it works. Now you might use your EBRAINS account to access such data. So we're also moving it even more to the left, and then things become much, much more rigorous in terms of controlling what's happening. So we are developing new systems in this regard. The strongly pseudonymized data are already served through something called Human Data Gateway, which goes through various steps and allows you to then, through an identification where you say, this is me, I'm identified through an EBRAINS account, and I accept all the conditions that apply, and I may then use some of the data. Then we also aim to make even more data available, and we are therefore now building a service for the so-called more sensitive data. So that will be important in the future as well. This is, of course, an area, I believe, which is of great global interest because we need to solve these challenges when working with human data. And now very briefly at the end, just a few comments about how we are using INCF resources and networks, and also how we interact with other initiatives through IBI. This will be very brief. So INCF is a broker between developers and HPP projects, producing metadata schemas for EBRAINS and leading ontology metadata experts internationally. So we basically have lots of connections with INCF when it comes to data and knowledge services. They also deliver knowledge-based services, which is also funded by the HumanBrain project. And they are a body for endorsement of standards and best practices, which is something we really need and everyone benefits from. And they're, of course, working for all kinds of projects and research infrastructures around the world in this regard. So here's a symbol for everything related to metadata. Here is a reminder of the knowledge space that you might want to look at and of the processes they have for standards and best practices. where they are actually accepting suggestions for standards and have a community reviewing process. And a reminder also that INCF has working groups, and you may even want to join them to help solve some of your problems. And of course, the training space is what we connect. Also, virtual masterclass series will be connected to the INCF training space. And then the IBI, and I mentioned a few things about the IBI. It organizes high-level meetings. We have one coming up in the European Parliament soon. It's a forum for interactions among brain projects, neuroscience societies, including EBRO, organizations and funders. And this virtual masterclass series is an example of something coming out of IBI. It has a set of aspirational goals and has a number of quite ambitious goals. And then just a comment on open science at the end. So open science, a research accelerator, very much focused on making knowledge of all kinds as openly shared as early as possible and in a practical way. It can be many different types of contents. In my presentation today, I focused on data, metadata, and also you mentioned we share code and software, but there are many other things that can be shared, of course. Open science is extremely helpful in order to move most fields forwards, and we're seeing it happening everywhere. As an example of this push is NIH initiatives, for example, in changing the culture of data management and sharing. High-level workshop that took place very recently in the National Academy. Then, of course, NIH are changing their policies also. So in the US, this is a big change happening at this point in time. Here's a slide to indicate this policy refreshment that will come in 2023. And the Society for Neuroscience is very active in this regard, and the European Union has a number of actions in this regard as well. So that's where we belong on our side, and we are very much supporting the open science policy at the European level. And this gives us a number of opportunities, as you can see here, summarized and reflected through the virtual masterclass series. Thanks very much.